So what we are going to do is this is the next question that usually comes. इसमें ये कि it's hydrolysis comparison of chlorine related compounds, or normally you get a big question on this as well. Hydrolysis comparison is that there are you get one big question. There are actually three different topics, but you get one big questions because there are three different chlorine related compounds. The first one is a chlorobenzene. It's got a benzene electron cloud, and it's got a Cl. Okay, so this is chlorobenzene. They're going to compare its hydrolysis, which is basically a reaction of water. किसका करेंगे with the halogenoalkanes. What are halogenoalkanes? They're basically carbon chains having a halogen attached to them. So you've got chloroalkanes, which is halogenoalkane. Okay, these are your and then you have a third compound, which is an acyl chloride. What is that? It's a carboxylic acid derivative. Okay, what you have is you've got a double bond O and it's got a Cl that's attached to it. And this is known as an acyl chloride. Okay, this one is the acyl group, serial bond OCl. So there are three different compounds, totally different compounds. Okay, but they're all chlorine related and they all react differently. So all of them react differently. You have no hydrolysis for the first one. Okay, absolutely no hydrolysis or reaction with water. For the halogenoalkane, what you have is you studied it in AS. Okay, AS में कर चुके. There were two different mechanisms. One of them was SN1 and you had an SN2 mechanism as well. So they did react with water. Not specifically with water. They reacted with NaOH aqueous. और plus उसमें you had to do reflux. So plus reflux. Okay, so you can say you have moderate reaction. The third one is the acyl chloride. What it did was, I mean, I haven't studied it yet, like what happened in acyl chlorides is they had a very vigorous reaction with cold water. And what you're going to get is बस ठीक है अभी फिलहाल very vigorous reaction with cold water. So ease of hydrolysis, it increases when you move to the right. Okay, the first one is not so ease of hydrolysis increases. Actually, one by one, starting with the first one, which is chlorobenzene. Okay, that's so we're going to discuss them in detail and the mechanisms for these three compounds. Okay, what you need to basically remember is acyl chlorides are going to have vigorous reaction. With water chloroalkanes, you have to heat them, reflux, NaOH aqueous. And the first one has no hydrolysis whatsoever. So starting with the first one, the question is, starting with the first one, chlorobenzene, right? So they're going to ask you why there's not going to be any hydrolysis for the first one. So, and they're going to ask you for the reason for that as well. So the reason for that is that if I draw the benzene structure, so that's the benzene ring, and you've got a Cl. Okay, now the reason it's not going to react with water is, I mean, the first thing is Cl has lone pairs. And it's got a lot of lone pairs. And those lone pairs are going to overlap with benzene's pi electron cloud. So what basically you have is the CCl bond increases in strength because you have more electrons over here. So at this point, you're going to have a lot of electrons because the lone pairs and the benzene electron cloud is going to overlap. So there's going to be a lot of electrons over here. ठीक है, इस जगह पे खास तौर पे you're going to have a lot of electrons. ठीक है, remember each of the carbon atom had a p orbital, and all of the lone pairs and these p orbitals are going to mix up. Because there's a very high charge density electron cloud at that point, the water molecule, which is a nucleophile, is going to be repelled because water also has lone pairs. And the oxygen water has a negative charge, has a partial negative charge. So the water nucleophile is going to be repelled because there are electrons already over here. ये बात clear है? Benil clear है? Ibrahim, Ishaq, Hala, is this clear?
Yes, sir.
Yes.
ठीक है, so बस ये लिखना है, ठीक है? So the way you're going to describe it is that remember it has to be described properly. Cl lone pairs. ठीक है, what do? They overlap with benzene pi electron cloud. And because of that, the CCl bond strength increases. Not only bond strength and charge density increases. So water is not going to be attracted to it. So, and it repels nucleophiles. So it's very hard to break the CCl bond because there's a lot of electrons. It's like a double bond now. So it repels nucleophiles, which in this case is your water molecule. Okay, that's it. That's chlorobenzene is done. Okay, no hydrolysis. Now, so the first one has no hydrolysis whatsoever. Here's second one, Ajata. This is your AS. You have to recap everything about AS. They will hydrolyze, but NaOH aqueous and reflux, right? And there's going to be SN1, SN2 mechanism. So we're going to do that quickly. So halogenoalkanes, Agla, that's so you have so you've got halogenoalkanes, SN1, SN2 mechanisms, right? So if I have a primary halogenoalkane, for example, I've got CH3, CH2Cl. So what's going to happen is that the Cl is going to be replaced or substituted. You would need NaOH aqueous, and you would have to heat with reflux. And your Cl is going to be knocked out. It's going to be replaced by OH. That's it. अच्छा, इसमें ये कि the primary halogenoalkanes, the primary ones, they undergo, if you don't remember, you've done this, primary halogenoalkanes, they undergo SN2. ठीक है, उनका mechanism क्या है? That's SN2. And what was SN2? That if you have a primary halogenoalkane where the alpha carbon or the one that's bonded to Cl is only attached to one carbon chain, it's got a very strong positive charge. Here the Cl is partial negative, so it's a very, very polar bond. And the reason it's got a very strong partial positive charge is that it's not surrounded by a lot of carbon chains, which are electron donating. So you don't have a lot of carbon chains, which is why the positive charge does not get electrons from a lot of places, which is why the positive charge is very strong. And if the positive charge is very strong, it attracts the negative Cl very strongly as well. So उससे क्या होता है कि the Cl, it's very hard for Cl to break away because the positive charge is like very, very strong. So Cl will not break away on its own. So what is needed is that you have to create the nucleophile first. So OH minus 1. The OH minus 1 comes in, it pushes the Cl away. So the OH minus 1 comes in, and its negative charge is going to push the Cl, which is also negative, away. And it's going to eventually knock it out. So your intermediate, there's going to be a transition state. And in that transition state, your molecule will be temporarily bonded. It will be bonded to, the CCl bond will be breaking, and the OH will be joining in. Okay, so this OH will slowly come close to that positive carbon atom, while the Cl will slowly be pushed out. Okay, so there'll be partial bonds. Carbon would temporarily, for a very temporary instant, would be making 5 bonds. This whole thing will have a -1 charge. Okay, and the reason it's going to be -1 is कि OH -1 is now attached to it. इसको हटा दे तो ठीक है. तो ये clear है, ये याद है? Mineral Isaac, Hala, is this clear?
Yes.
और फिर क्या कि eventually the Cl breaks off. So you have CH3, you have CH2. The OH has now permanently joined with it. And the Cl -1 has been knocked out. I say ये कहना total, that's your transition state. It's not an actual state. It's not an intermediate state. It's just something that forms for a very temporary instant. Remember, this entire mechanism is a one-step reaction. It only has one step it's only got one step, and the reason it's called SN2 is that the 2 indicates that rate of reaction depends on both reactants because there is no slow step. So rate depends on both reactants. So basically, reason they're going to ask you why does this follow this mechanism, because it's hard for the carbocation to form. It's hard for the Cl to leave on its own because the carbon has a very strong positive charge. तो इसका आप लिखोगे कि why SN2? So the reason for the mechanism is that a 1 degree or a primary carbocation is hard to form, and it is very unstable. But to the point, like, it's very unstable. Why? Because it has fewer electron rating. Alkyl chains. There's not a lot of things around that can contribute electrons to this positive charge. So the positive charge is like really strong. So it has fewer electron rating alkyl chains, and because of that, what happens is that hence carbocation has high positive charge density. Yeah, hence नहीं and इसको and कर लेते हैं. तो ठीक है, ये clear है. SN, I mean that's what you've already done. SN2 clear, Qasim, Minal, Ibrahim clear है, Isaac.
Yes, sir.
अच्छा, दूसरा क्या था? the tertiary halogen alkane, ठीक है, वो भी quickly कर लेते हैं. अच्छा, tertiary one was कि what happened कि the carbocation would form because it's easier to form the carbocation. ठीक है, तो उसका जो the SN1 mechanism is कि you've got CH3, you've got 3 carbon chains. So the partial positive carbon is surrounded by electron donating carbon chains. So the positive charge is not going to be very strong, which is why the Cl is not going to be attracted very strongly to it. So the Cl can leave. And when it leaves, a carbocation easily forms. Okay, so in this case, the Cl is going to leave, and Cl is going to have a -1 charge, and the carbocation can easily form. Again, the positive charge is not going to be very strong because it's getting electrons from its neighboring electron donating carbon chain. So the positive charge is not strong enough, and it's not going to attract the Cl that much. So the Cl can break away on its own. And when it does break away, the nucleophile OH-1 comes in. And if the concentration is high enough, it's going to go and it's going to connect with this. Okay, and that's it. तो फिर आपका वो बन जाता है, इधर ड्रॉ कर लेते हैं. So finally your OH joins in. So now this is a proper intermediate state. Now this carbocation is something that is actually formed. And this one is a proper two-step reaction, which has a slow step. The first step is your slow step, which is why your rate only depends on the slow step. So that means rate is only dependent on the first step, which is rate. Or first step में क्या है? It's your halogenoalkane. So rate depends on halogeno. किसका spelling है इसके? Halogenoalkane concentration. ठीक है? And अच्छा बाकी ये कि the reason for this, we're going to write the reason, which is a C degree or a tertiary carbocation has more electron donating alkyl chains. So it has more electron donating alkyl chains. So carbocation is more stable so it's easier to form. Carbocation is more stable. And has lesser positive charge density. So ठीक है, that's SN1, SN2 mechanisms of halogenoalkanes. ठीक है, और इसमें मैंने यहाँ लिखा हुआ है yeah, NaOH aqueous. Those are the conditions. ठीक है, you get a moderate reaction. That's it. चलिए ये क्लियर है सारों को? इसाक, हाला, इब्राहिम, मिनल, कासिम,
Yes,
क्लियर है?
sir.
Yes.
Yes,
अच्छा
sir.
अब चलो ठीक है, अब ये हो गया. ठीक है, we're done with the second one, which is halogenoalkane. With the halogenoalkane, ठीक है, chlorobenzene is done. उसका तो होता ही नहीं था hydrolysis. Halogenoalkane is done. Now we have to do the last one, which is the new one, which is acyl chloride. They have vigorous reaction, very vigorous reaction. And अच्छा उसमें है कि so acyl chloride. अच्छा so very vigorous reactions. Now, uski reason bhi kar lete hain, the first thing is, what is the reaction? It's so when you have any acyl chloride, so let's say you have remember the acyl group is acetyl bond O and Cl. You just add it to water, even with cold water. So whether it's cold or warm ke saath, it's going to be very explosive. So the OH from water comes in and it knocks out the Cl. And where does the Cl go? It reacts with the H from water and forms HCl. Which is why you're not only going to see a vigorous reaction, you're going to see white steamy fumes of HCl as well. Okay, so white steamy fumes of HCl are going to be formed. The reaction acyl chloride. Now the question is, why is it so vigorous? That's one of the questions. And the answer is pretty simple. The carbon over here has a very, very strong partial positive charge. Why does it have a very, very strong partial positive charge? Well, because it's bonded to two very electronegative atoms. And they are pulling the electrons away from it. So the nucleophile, which is water in this case, is going to be very strongly attracted to it. Because that's the simple reason. Okay, the positive charge is extremely strong, and the water is going to be very strongly attracted to this. So reason लिख लेते हैं कि carbon in RCOCl is bonded to two very electronegative atoms. And has a strong partial positive charge density. Which then attracts electrophiles very strongly. ठीक है, ये सारों को क्लियर है? Ibrahim Isaac Khalid, is clear?
Yes, sir.
So it's a very, very I'd say it's a very, very strong partial positive charge. अब इसका mechanism ये कि the whole mechanism for this reaction. So it's kind of a complex, it's a new mechanism. This is called nucleophilic addition elimination. Okay, there's going to be addition happening, and then there's going to be elimination happening. Yeah, this it's going to be a 3-4 mark mechanism. To start वहीं से होगा, you've got RC double bond O Cl. ठीक है, the carbon is very positive, the Cl is partial negative, the oxygen is also partial negative. The water molecule comes in. Okay, so here's your water molecule coming in. The water molecule has lone pairs which have partial negative charge, and these lone pairs are going to be very strongly attracted to the carbon that's positive. Baki we call it negative, this is positive. Anyways, while this lone pair, the negative charge, gets attracted to the carbon that's positive, the double bonded electrons get repelled. They get repelled. Why are they getting repelled? Because there's negative charge coming in, right? So as the negative charge comes and attacks, the electrons that are over here, they get repelled. Just one second. Just one second. अच्छा ये क्या repel हो गए ठीक है so those electrons are repelling and next step is the double bond breaks and the electrons they accumulate at the top while what happens at the bottom is that the oxygen with its lone pairs goes and bonds it goes and bonds and there's only one lone pair left which is why the oxygen over here is going to be it's going to be positively charged because it gave its electrons to carbon and these electrons they get pushed to the other side. अच्छा ये हो गया and there was a Cl that was also attached over here which didn't go anywhere. The Cl is still there and it's still partial negative. Now that's your intermediate that's forming. Now the next step is the lone pairs that are at the top, the negative charge, that's got nowhere to go. So those electrons come back and they reform the double bond. And when that happens, the Cl electrons, they get repelled and the Cl gets knocked out. Okay, so that's your next stage. So this is what's going to happen next. So this double bond over here gets reformed. Okay, so you're back to a double bond. And the Cl has now taken its electrons and has gone away. As a final stage is that this Cl over here is going to come back. So the final step is this one. If this Cl comes back, the oxygen already had a partial positive charge. Thank you. Put the lone pairs here. The oxygen was missing its lone pairs because it had given those electrons to carbon. So Cl comes in, steals the H, and what does the H do? It leaves its electrons over here and gives the lone pair back to oxygen over here. And that's your final stage. Okay, that's when carboxylic acid gets formed and HCl gets formed. So the final step is the Cl has turned into, it's taken the H. It's a little bit harder thing. It's taken the H and it has now become HCl. And over here you have OH, which is now a carboxylic acid. So that's your entire mechanism. Let me just put it. Yes, it's probably one of the longest mechanisms that you're going to study. But everything has to be यहाँ से अच्छा, so but if you just follow the steps, it's not that difficult. The first thing is that the lone pairs on oxygen, they attack the carbon, which is positive, which is very strongly positive because it's bonded to two very electronegative atoms. The electrons in the double bond, they get repelled. So the water molecule gets attached at the bottom and the double bond electrons are sitting at the top. They come back, they reform the double bond while the Cl gets knocked out. Because the Cl leaves and the water is still attached at the bottom. The Cl comes back and then the water had a problem with that. It was its oxen lacked a lone pair because it lost a lone pair initially. So Cl comes back, steals one of the H's. The H then gives the lone pair back to the O, and that's basically your OH left because the H is gone as well. And you basically now at the end of the day you have a carboxylic acid and you have an HCl gas molecule that's going to be formed. ठीक है? So the first step is your addition. And after the first step, elimination starts happening. Things they start breaking off. ठीक है? The Cl leaves, then the Cl comes back, takes the H as well. So you have addition initially, and then you have elimination. चलिए ये clear है सारों को, this one?
Yes, sir.
So that's all you get. A lot of times you get one big question on और हमेशा comparison किया जाता है, hydrolysis comparison. So remember, you should be able to identify. So I'm just going to recap everything. You should be ये तो 3-5 देखते हैं उसके बाद था. So remember, you should be able to identify the halogen compounds, especially chloro compounds. ठीक है? Chloropentene, chloroalkanes, and acyl chlorides. You should know which one is what. Because obviously they're going to change this. But remember, if it's Cl with a acetyl bond, that's an acyl chloride. If it's just a Cl in a carbon chain, that's a halogenoalkane. If it's a Cl with a benzene, so that's a chlorobenzene. Uska koi hydrolysis nahi hai. Chlorobenzene, the first one, it will undergo no hydrolysis. That's the first one. Halogenoalkanes, wo AS wala hai, that's SN1, SN2 mechanisms. They will undergo hydrolysis, but you heat them and you have to add NaOH to it. You're going to have SN1, SN2, and then you have acyl chlorides, which is you're going to have very, very vigorous hydrolysis, because the carbon has a very strong partial positive charge, so it attracts nucleophiles very, very strongly. And this is the entire mechanism of an acyl chloride undergoing hydrolysis. So you got to remember this entire mechanism as well, and that's it. तो ये हो गया, हमारा हाइड्रोलिसिस खत्म हो गया. तो कल करते हैं वो, we'll do comparison of acids and we'll do comparison of bases. ठीक है?
Okay, sir.
Okay. Everyone
Love.
take. Love has.